In Moscow Institute of Steel and Alloys, development of the single-stage liquid phase process started in 1978. The first patent in Russia was obtained in 1979. To test the process feasibility, a pilot commercial plant with the hard area of 20 square meters was built at the Novolipetsky Steel Works in Lipetsk, Russia. During 1985–1998, 41 campaigns were performed. Each included startup and slowdown, with full tapping of metal and slag from the furnace. More than 40,000 tons of hot metal were melted and used further in basic oxygen furnace for steel melting. The Romelt process is a continuous single-stage method of obtaining hot iron from an iron-bearing raw material in a slag bath, with the use of abundant, inexpensive grades of non-coking coal. The products of the refining operation are liquid hot iron, slag with a low sulfur content, and a high calorific value gas. Romelt hot iron contains significantly less silicon and manganese than blast furnace hot iron, which allows it to be more effectively used in the charge of electric steel-making furnaces. The gas can be used to make steam that can be employed in the heating and electric power plants. The general scheme of the Romelt furnace is shown in figure. In Figure 1, agitated slag. 2, sump for slag. 3, sump for hot metal. 4, hearth with refractory lining. 5, channels for slag and hot metal. 6, PE tunnel. 7, gas escape branch pipe. 8, lower 2 ears. 9, upper 2 ears. 10, calm slag. 11, water-cooled panels. Iron-containing materials, coal and plugs, are fed using weigh hoppers from the relevant bins to the common conveyor. The charging into the furnace is performed through the aperture in the furnace roof. No preliminary mixing of charged materials is needed. It takes place directly in the slag bath due to its intensive agitating. Sluice arrangements used in the units for other processes that operate under pressure are not needed in the Romelt furnace. The working space of the Romelt furnace is under negative pressure, which is ensured by an induced draft fan. The bath of melting slag is blown with an oxygen-air mixture through the lower two ears positioned below the slag layer. The two ears have simple structure and prove to be reliable in operation. They ensure the required agitating power of the slag bath. Getting into the agitated slag that contains coal, iron-bearing materials are reduced. Iron, produced by the reduction, becomes enriched in carbon. Drops of melted metal precipitate under gravity on the furnace hearth. Thus, three melted layers are formed in the furnace: the layer of metal on the furnace hearth, the layer of calm slag between the metal and the lower two ears, and the layer of agitated slag, the reaction zone. There is about 70 tons of metal and 100 tons of slag in the furnace. Two lined chambers, sumps, are situated each at one of the end sides of the furnace. They are used for separating of tapped metal and slag. The sumps are connected with the working space by channels of different heights. This ensures separate transportation of metal and slag into the metal and slag sumps. There are holes for tapping metal and slag, which are located at different heights. That ensures continuous free tapping of the melting products at the speed that matches the unit capacity. If the furnace has little capacity, tapping may be arranged periodically. In the slag bath, the heat expense on melting and reduction of the burning materials is greater than the heat received from the burning of carbon into carbon monoxide near the lower two ears. Thus, the main peculiarity of the process is the post-combustion of carbon monoxide, hydrogen, and coal volatile matter evolving from the bath by the oxygen blown through the upper two ears. Post-combustion of the gas up to carbon dioxide and water allows to return the heat into the slag bed and to maintain processing of raw materials. The hearth and the lower part of the furnace bed, which contains permanently metal and calm slag, are lined with refractory bricks. In this zone the refractory lining is under favorable conditions, at the suitable temperature and out of the oxidizing effect of the atmosphere. In the zone of agitated slag, the furnace walls are constructed of copper water-cooled panels. Formation of the slag lining on them reduces the heat losses and their wear. That allows to avoid destruction of the lining in the places of the most aggressive attack of gas slag metal emulsion. Above the slag bed, walls are made of steel water-cooled panels. After post-combustion, gases flow through the water-cooled gas escape branch pipe at a temperature up to 1700 degrees Celsius into the waste heat boiler. They are burned completely with natural air inflow and cooled to 250–300 degrees Celsius. Of gases are transferred to the gas cleaning system and discharged into the atmosphere through the chimney. Flue dust ejection from the unit, measured in the gas escape branch pipe, is on average about 3% of the weight of the charged materials.